In our last two videos, we built a solid foundation for form handling in Flutter. We talked about text form field widget, form widget, global key, and how to implement proper validation along with some best practices. But you know what? Having validation is not enough. The difference between a good and a great form is in the small details. The little UX improvement that makes our app feel polished and professional. Today, we are going to take our login form to the next level with these three powerful UX improvements that your users will absolutely love. So let's dive in. Let me quickly show you where we are starting. Here is our login form from the previous video. We have our basic form with the validation, but it's missing those polish touches. Let's fix that one enhancement at a time. The first enhancement is something we actually touched on briefly in the last video, but let me explain it in more detail because it's so important for user experience. Right now, our form validates when user clicks login button, and that's good for the first attempt. But what happens after they see an error? They start fixing it like this. But they won't know if it's correct until they hit login again. And that's frustrating. What we want is an intelligent validation. We don't want to annoy users while they are first filling out the form, but once they have submitted it and seen the errors, give them immediate feedback as they fix those errors. To implement this properly, we need to track whether the form has been submitted at least once. And for that purpose, let's create a Boolean variable called as attempted submit. And let's set it to false by default because the user hasn't tried to submit yet. And this variable will help us control when real-time validation should kick in. Hit save. Now let's update our submit method to set this flag to true when user attempts to submit. And let's wrap this inside a setState method like this so that whenever the variable changes, we can update our UI. Hit save. Now here is where the magic happens. Let's use this Boolean variable to conditionally set the auto validate mode on our form widget. So let's go to form widget and let's use the auto validate mode property. If the Boolean variable is true, then set auto validate mode to on user interaction. And if it is false, then set auto validate mode to disable. Hit save and let's restart the application. Now let me explain exactly how this works step by step. Currently our Boolean variable has attempted submit is false. So the auto validate mode is set to disable. No validation happens as the user type. They can fill out the form freely without annoying error messages. And now the moment I click the login button, here is what happens behind the scenes. Let's go to our submit form function. First, we change our Boolean variable has attempted submit to true in a setState function, which will trigger a rebuild. Next, we call the validate method, which will trigger the validation and the errors appear. After the rebuild, the form widget evaluates the auto validate mode. And now here is the magic part, real-time validation. Since our Boolean variable has attempted submit, it's set to true. The auto validate mode is set to on user interaction. And watch what happens when I start fixing the email. As soon as the field becomes valid, the error goes away. Let me do the same for the password field. Currently, we are getting an error. Please enter your password. And if I start entering the password, we are getting an error. Password must be at least 6 characters. And if I enter the password greater than 6 characters, the error goes away. Let me demonstrate this one more time. Let's restart the application. Currently, both fields are empty. And notice we are not getting any errors. It's because we haven't submitted our form. Now let's start entering an invalid email and password less than 6 characters. Hit login and validation error shows up. And here is where the real-time validation kicks in. Now if I start fixing the email field, the error goes away as soon as the email field becomes valid. And let me do the same for the password field. Enter password greater than 6 characters. The error goes away as soon as the password is greater than 6 characters. And if I clear the password field, the validation error shows up again. This is the professional approach to form validation. Users are not annoyed by displaying the errors upfront, but they get the helpful real-time feedback when they are actually fixing the issues. Next up, let's talk about keyboard actions. Right now, to fill out this login form, first user tap on the email field. They type their email. Then they tap on the password field, type their password, and then tap on the login button to submit the form. That's too many steps. What we want is this. When user finish typing their email, they should see a next button on the keyboard that automatically moves them to the password field. And on the password field, they should see a done button that submits the form directly. So let's implement this. First, we need to tell each text form field what action to display on the keyboard. And for that purpose, we will use text input action property of the text form field widget. For email field, we will use text input action dot next because we want users to move to the next field. And for the password field, we will use text input action as done because this is the last field in our form. Now, to trigger the form submission when user press the done button on the keyboard, we will use on field submitted callback of password text form field widget where we will call submit form function. Hit save and let's restart the application. Now let me show you how smooth this is. User can enter their email, press next on the keyboard. Notice that we are in the password field. Now they can enter their password and press done on the keyboard and the form submits automatically. No manual navigation, no closing the keyboard, no tapping buttons, just pure efficiency. This is very powerful UX improvement as we have eliminated multiple steps and made the entire process feel smoother and faster. Now let's tackle another common annoyance, the keyboard staying open when you don't need it anymore. When users are done typing or they want to see more of the screen, they should be able to tap anywhere outside of the text field to close the keyboard. But right now the keyboard just stays there, blocking the view. The solution is to wrap our scaffold in a gesture detector. Like this. Let me break this down. The gesture detector widget detects touch gestures. By wrapping our entire scaffold with it, we are saying listen for taps anywhere on this screen. And when a tap is detected, the on-tap callback is triggered. And inside it, we call focus scope of context.unfocus method, which will close the keyboard. Now let me demonstrate. I will tap on the email field and the keyboard opens up. Now I will tap outside anywhere on the background and the keyboard closes. If I tap on the email field again, the keyboard reopens. This is exactly the behavior users expect. This simple addition makes our app feel so much more responsive and user-friendly. It's a small detail that users might not consciously notice, but they will definitely feel the difference. And that's it. I hope you found this video helpful. Hit like and subscribe for more awesome Flutter content. Until next time, keep coding, keep learning, and I will see you in the next video. Happy coding!